Take down the first question. No, 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 no.
Repeat now.
Tomorrow, next class. Take down this question. First question. Take down first question. Come on. Don't waste time. Time is very precious. Make use of it. Okay, tell me, can you do this first question? First question, read the first question. Come on. I'm just trying to zoom it as much as possible. Can you see the first question? I'm trying to zoom it as much as possible for you. Okay, take down the first question. Come on, come on, come on. You give me the answer now. I have already taught you this. What is the answer for this? A 12-bit. First question. Take down the first question. Take down the first question. Come on. Can't you see this now? You can see this, right? Oh God, I think you have to go to ophthalmologist. Right? Okay, a 12-bit register is having this content. See, 1000, 1001, 0111. What is the content if it represents a BCD? See, suppose if this is a BCD, what is the value?
897.
If it is BCD, this is 8, 9 and 7. If it is not BCD, can you get me the value? Come on, do it fast, do it fast. Fast. If it is not BCD, how do you get, if it is a binary number? If it is a binary number, come on. Come on, fast. You are all very good students. If it is not binary, what is the value? Come on, do it. 2199. Yes. If it is not binary, this is 2199. So how do you get that? Same thing. Multiply this with 2 to the power of 0 plus multiply this with 2 to the power of 1. As usual, you convert your binary number to the decimal number. That's all. From here, left to right. Okay? Be careful. Don't start from here. It's wrong. Fine? Okay. First question is over. Second question. We will not do all this, but some of this we will do. Now see here. See the second question. This is for your parity. Right? This is for your parity. Right? Okay. Now just tell me, in an even parity scheme, see this is the even parity scheme, which of the following words contain an error if leftmost bit is a parity bit? If leftmost bit is the parity bit. Come on, tell me. Even parity, right? 1, 2, 3, 4. This is all right. Now this one, 1, 2, 3, 4, 5, 6, all right. But this one, 1, 2, 3, 4, 5. So this is in error. Okay, it's all simple question. Okay. Now see here, see the next one. Third one. See the third one. Come on. If in odd parity scheme, which of the following words contain error if leftmost bit is a parity bit? Tell me. 1, 2, 3, 4, 5, 6. This is an error, right? Now, 1, 2, 3, 4. This is an error. Right? Now 1, 2, 3, 4, 5. This is not in error. Done. Now, fourth one. All these things I have taught in my previous class. Okay, I'll be sharing you all the videos and other videos also where you can understand easily. Make use of everything. It is all for you. Right? It's all for you only. Make use of that. If you want to get better grades, want to understand, if you want to do that, you can do it. Right? Okay, fine. Can you do the fourth one? Can you give me the answer for fourth one? Gray code. I told you how to get the gray code. Right? First bit will come as it is, as a 1. Next bit will be XOR of 1 and 0. What is the XOR of 1 and 0? 1. Next bit will be XOR of these two. 1. Next bit will be XOR of these two. It's going to be 1, 1, 1, 1. Okay, let us do the fifth one. The one which you did yesterday. Right? This is very important. All of you have to do it in your notebook. Okay? Now, fifth one. Fifth question. Generate the Hamming code for transmitting 11010. See here. For transmitting 11010 data with the parity bits as a even parity. With the parity bits as even parity. Okay, let us start now. Okay, so how do you start now? You have to generate a Hamming code. You have to generate a Hamming code. Can you do it yourself? Now, tell me, what is the message length here? 5 bits, right? So now start with this. So, what is the message? 11. Let me check. 11010. 11010. This is the message bits. Okay? You know 2 to the power of p greater than equal to p plus m plus 1. What is m here? M how much? M is 5. Why m is 5? Because there is a message bits, 5 message bits. Okay. Now you just see 2 to the power of p greater than equal to p plus 6. Right? Can you tell me which p is going to match this relation? 4, right? 4 is going to match your relation. So what you do is 2 to the power of 4 greater than equal to 4 plus 6. That is your 16. 16 is greater than equal to 10. So this satisfies. Since it satisfies, what is p now? What is p? What is the length of p? 4. This is done. Okay. Now, so totally, what is the total length of the Hamming code now? 5 plus 4, it is 9. So just write here 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Fine. Okay. Now tell me where and all you will have this parity. There are 4 parity bits, right? There will be P1, there will be P2, there will be P3, there will be P4. Right. Now tell me where and all you will have a parity bit now? So there will be one parity bit here, then second one here, third one here, and fourth one will be at P here. P4 will be here, right? Okay. Now you tell me, I said power of 2, right? Wherever yesterday you were in the class or not? Power of 2, whichever number is power of 2, you fix the parity bits. First one is power of 2, right? 2 to the power of 0. Next one 2 to the power of 1. Next this is 2 to the power of 2, this is 2 to the power of 3. So power of 2, whichever number is power of 2, you are going to fix these parity bits. I told you this yesterday. Is it okay now? Have you understood? Okay. That's why every class you try to update. That's the purpose I record my lecture and send it to you. And if you come blank in the class, don't do that, right? Have you understood this? Okay. Now, where and all you have message bits? This is your M1, right? This is your M1, this is M2, this is M3, this is M4, this is M5. So, where M1 will come? Here you will have M1, this is your M2, M3, M4 and M5. Right. Now, how do you find out the parity bit P1, P2, P3, P4 now? You have P4 now, right? You will have P4. Now, once again, which are the combinations? First tell me which are the combinations you are going to use. I will rub this, okay? I will rub this. Now, okay, I will write P1, P2, P3, P4. Listen carefully. Okay, you have during last class you had only P1, P2, P3, right? Now you have P1, P2, P3, P4, right? So that's why now write all the combinations, right? So 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, okay. Now next 0, 1, 0, 1, now 0, 1, 1, 0, now you have this 0, 1, 1, 1, right? Okay. Now next, see how many positions you have here, only 9, right? Do you need to write all 16? Not required, right? See, all 16 combination is not required. Your possible combinations are 16, right? But it's not required. Only till 9 you write. Okay. Now next will be 1, 0, 0, 0, right? Next will be 1, 0, 0, 1. See, you have only 9 numbers there, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. Now, for P1, which are the combinations you take? You just take wherever you have 1. Which are the bit position numbers you are going to take? 1, 2, 3, 4. This also you have to take. This will be, how do you calculate P1? How do you calculate P1? I said you take the combination of, this is going to be your P1 only, right? This is going to be P1 only. Now see here. P1, next, bit P1, comma, third position. What is there in third position? M1. What is there in fifth position? M2, right? What is there in seventh position? M4. What is there in the ninth position? M5. To get the parity bit P1, right, you will have to see the bits at position 1, position 3, position 5, position 7 and position 9. Now P1 is the parity bit which you need to add, right? You were there in the last class? Right. I can't repeat what I did in last class. Right? Just listen here. Your parity bit P1 can be got from the combination of bits, okay, combination of bits, bit position, and that bit position can be got from this column, okay, wherever you have this 1. See, in this column, in P1 column, at 1 you have 1, 3 you have 1, 5 you have 1, 7 you have 1, 9 you have 1, right? Now see here, all this bit position you have to take. Okay, what is there in the bit position 3 here? M1, right? M1. What is there in bit position 5? M2. What is there in bit position 7? M4. What is there in bit position 9? M5. And this position like 1, 3, 5, 7, 9, all this will come from this column where you have all ones here. Have you understood now? Right. Now in this you see, this is your P1 only, right? And all this you have from the message bits. Now tell me, now what is P1 now? Now what is M1? What is M1? Come on. What is the question we have? 1, 1. Yeah, 11010. 11010. Where is this? This is 1. I will take some other color. Okay, this is 1, right? This is 1. This one 0. This is 1. 1, right? Okay. This is 0. Okay. Now, I will keep P1 as it is because we have to find out what is M1? 1. What is M2? 1. What is M4 is 1. This is also 0. So, what type of parity they have asked? Even parity. So, this entire combination should have a even parity. That means what is the P1 now? P1 is definitely going to be 1. Right? Okay, now we got P1. What is P1 now? P1 is 1. P1 is 1. Okay, now P1 is 1. I will write 1 here. P1 is 1. How do you get P2 now? Which are the combinations you have to take?
2, 3, 6, 7.
You should take this, 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 this. You will be taking from 2, 3, 6 and 7, right? So you will be taking from 2, 3, 6, 7. Okay, what is there in 2? P2 itself, right? This is what you have to find out now. What is there in 3? M1. What is there in 6? M3. What is there in, last one is 7? M4. Okay, now tell me, what is this? M1 is 1,
0.
M3 is 1, M4 is 1, right?
M3 is 0.
M3 is 0, sorry, M3 is 0. Yeah, M3 is 0. Okay, now tell me what will be P2 now? 0. Why P2 is 0? Because you have to make total number of bits equal to even. That's why we are making this as 0. Now you got P2. What is P2? P2 is 0. P2 is 0. Can you get me P3 now? P3. From where P3 will come? From here, from here, from here, and from here. So that is 4, 5, 6, 7. Right? 4, 5, 6, 7. 4, 5, 6, 7. See what is there in fourth position? P3 itself. This is what you have to find out. What is there in fifth position? M2. What is there in 6? M3. What is there in 7? M4. Okay. What is M2? M2 is 1. Right? What is M3? 0. What is M4? 1. Okay. So can you tell me what will be P3 now? 0. P3 will be 0. That means P3 is going to be here 0. Done. You got the Hamming code now. What is the total? What is the complete Hamming code now? Oh, of course. Oh God, we forgot P4. You know, tell me from where and all you got the P4? You get it from 8 and 9. That is 8 will be your P4 only, right? See, I will write it here. 8 and 9. 8 will be your P4 only, right? Now 9 will be your M5, 0, right? Right. Now you have to make it as a even parity, right? That means you add 0 only. If you put 1 there, it will become odd parity. So you make it as 0 only, 0 only. So you got now all the parity bits, right? All the parity bits you got now. So everything you got. This is called as parity bit generator. right? Of course, if number of message bits goes more and more, you will need a lot of time to do that, right? As I told you that suppose if the message bit is of 8 bits, right? So you need how many parity bits now? 3 or 4? Suppose message bits 8. What is the number of parity bits required? 4, right? The work will be same, but there you will have, what is the total message length? 12. So you will have something like 10, 11, 12, like that, right? Okay? Have you understood how to extend this for more number of message length? Right? Right? You will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this you are going to extend till how many places? Till 12, till 12. So last P4 will be now, what are the combination for P4 now? If your M message is of 8-bit length, what are the P4 combination? So then you will have 10 here, 1, 0, 1, 0, 11, 1, 0, 1, 1, 12, 1, 1, 0, 0. Now tell me, where and all you have 1 here? Here you have 1, right? Have you understood this? What are the combinations you have to take? Take from 8, 9, 10, 11, 12. These bits you have to take. You may get on question on this, definitely, okay? Try to practice this. I will give you one homework for you. Just can you do this? I will give you any random one question to you. See here. See continuation to this. See continuation to this. Listen carefully. In continuation to this, get the Hamming code for 1101, 1011. Get the Hamming code for, I want you to do this, okay? Another practice for you. 1101, 1101, 1011. This is the message bit. This is the message bits. Okay, get the Hamming code for this. Come on, who will do it fast for me? Okay, consider it as a odd parity. Odd parity. For odd parity, you get the Hamming code. Come on. Can you tell me what is the parity bit required? Number of parity bits? 4, right? Hope all of you know how do you get this 4. All of you know at this point of view. Don't remain with any doubts, right? I have explained you this already and I have shared you a lot of videos also. Please go and refer to that. Okay? Number of parity bits are 4, right? Okay. Now, what is the total length of the Hamming code? 12. You put it like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can you tell me where and all parity bit will come? So first parity bit will come at here, right? Yes or no? Come on, you people are not. First parity bit will come here. Okay, where the next parity bit will come? Next parity bit will be here, P2. Okay, where the next parity bit will be? P3. Then P4 here. Okay, where and all message bit will come? Suppose if we take this as M1, M2, M3, M4, M5, M6, M7, M8. So this is M1, M2. I will use nice colors. Okay, This is your M1, M2, M3, M4, M5, M6, M7, M8. Now, I'll go to the next page. P1, P2, P3, P4. Okay? Now you are going to find out P1, P2, P3, P4. Okay, till how many combinations I have to go now? 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, then 0, 1, 1, 1, 1, 0, 0, 0, this is 8, 1, 0, 0, this is 9, 1, 0, 1, 0 is a 10, 1, 0, 1, 1, 11, then 1, 0, 1, 1, 0, 0. Right? I will write the number also here. Okay, I'll take some color. Okay, this one. I'll write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so what are the combinations to be taken for getting P1 now?
1, 3, 5, 7, 9.
Here 1, 3, 5, 7, 9 and 11. Okay? Now, can you tell me what are the combinations you have to take for P2?
2, 3, 6, 7, 10, 11.
See, for P1, I will write here. For P1, I will write here P1, comma. Now here you will have position 3. See, I will just take the position only, okay? I will write here, wait. So how to get P1? P1 can be got from the position 1, 3, then 5, 7, 9 and 11. Right? Now what is there in 1? It is P1 itself, right? This is what you have to find out, parity bit. Now what is there in 3, 5, 7, 9, 1, 9, 11? Refer to your other one. Come on. 1, 3, 5, 7, 11. 1, 3, 5, 7, 11. Okay? See, 1, 3, 5, 7, 11. What is there in 1? This is P1 itself, right? What is there in 3? M1. What is this? This is 1, 1, 0, 1, 1, 0, 1, 1. Okay, tell me, come on. What is there in 3? 1. What is there in 5? 1. What is there in 7? 1. What is there in 11? 1. Okay, can you tell me what is P1 now? It is supposed to be odd parity. Odd parity. Come on. Eleven is also 1. No, that's why. What is total number of 1 should be equal to? Oh, there's a 9 I'm missing, right? Yes. 1, 3, 5, 7, 9, 11. Exactly, exactly. All ones, right? All ones. So what will be P1? 0. So P1 will be equal to 0. P1 is 0. So write 0, this is equal to 0. What is P2 now? How do we get P2? Come on, how do you get P2? 2, 3, 6, 7, 10, 11. What are the combinations you have to take? See here. 2, 3, 6, 7, 10 and 11. Okay? 2, 3, 6, 7, 10, 11. Okay. Anyway, at 2 you have P2 itself. This is what you have to find out, right? Okay. Now tell me what is there in 3?
1.
What is there in 6?
0.
What is there in 7?
1.
What is there in 10?
0.
What is there in 11? Okay, can you tell me? Parity bit P2 has to be 0. Why P2 has to be 0? Because odd parity. So total number of ones has to be odd. So if I put 0 here, then only total number of ones will be odd. So what is P2? Now P2 is going to be also equal to 0. Okay, now tell me, how do you get the combination for P3?
4, 5, 6, 7.
So for P3,
4, 5, 6, 7, 12.
so P3, I will write that 4 will be P3 only, okay? This is your P3 only, this is your P3. Okay, then, comma 5, comma 6, comma 7, comma 12. Okay? How do you get P4? P4 is C. 8, 9, 10, 11 and 12. Okay? So 8, this is going to be P4 only. This is going to be P4 only. I will not write that. Then you will get from 9, 10, 11, 12. Can you tell me what will be P3? 0. What will be P4? 0. So all are 0, 0, 0, 0. Right. So this is also equal to 0. This is also equal to 0. This is for odd parity. Odd parity. Right? Okay. Now let us go and do the one more problem. Hope we have still time. Okay. Can you do the sixth problem? Sixth question. Sixth question. Following is the Hamming code. Following is the Hamming code received with even parity. Listen carefully. Now you have received an Hamming code. This question is not to generate an Hamming code. Okay? This question is not to generate an Hamming code, but you have to find out which bit has an error. Right? Last class I told you how to do that. We will do that, don't worry. Okay? Please find the error bit if any. It is not told that there is any error or not. Right? It is not told there is any error or not. Okay? So you have to find out, is there any error, right? Okay. Now I have told you in my last class, I will explain you once again how to check the error, right? Okay. Now take down this. I will just go to the actual black screen. Now 10 10 111. Okay. 10 10 111. Received message is 10 10 111. Yes or no? Right? This is the received message. Right? Now can you tell me what is this according to your Hamming code? This is your P1, right? What is this? P2. What is this? M1. What is this? What is this? No, power of 2, my dear. This is P. This is P3, right? This one, M3, sorry, M2, M2, M3 and M4, yes or no? Now you check. So how do you get P1 here? What are the combinations you have to check? This is your position 1. This is 1, 2, 3, 4, 5, 6, 7. Okay. So how do you check your P1 is correct? How do you check this combination? You have to check 1, 3, 5, 7. You check the bit combination in this. What is there in 1? 1. What is there in 3? Come on. In 3, 1 you have. Okay. So in 5 you have 1. In 7 you have 1. So what is E1? 0 means no error. This is E1, right? No error. Right? There's no error. Now, do the same thing for P2. Do the same thing for P2. Can you do it for P2? How do you get your P2? What are the combinations you have to see? 2, 3, 6, 7. Can you tell me what is there in 2? In 2 you have 0. In 3 what you have? 1. In 6 you have 1. In 7 you have 1. There is an error. That means your E2 is equal to? No, what it just tells, what is the question? Odd, right? Even parity. 1 minute. 1 minute. Let me check the question. This is error, right? No, I will tell you, don't jump. Okay? Don't jump. This is okay? Okay. What is P3? What are the combinations you have to check in P3? 4, 5, 6 and 7. Okay, what is there in 4? 0. Right? And 1, 1, 1. So this is also in error, right? E3 is equal to 1. Just go from E3 to E1. So you get 1, 1, 0. Convert this into decimal. This is 6th bit. So 6th bit is in error. So this bit is in error. That means it is supposed to be 0. Error means it became 1. So what is your corrected message now finally? What is the corrected message? Your initially message was, what was the message? Message which is received was 1, 1, 1, 1, right? See, I'm talking about only message bits, right? See, your message what was received is 1, 1, 1, 1, right? But after checking it for an error, you found that this is in error. This is supposed to be 0. So that means the correct message which was transferred is 1, 1, 0, 1. You have detected one error and also you have corrected it. You have corrected it, right? See, suppose if you have detected one error in bit position 6 and bit position 6 shows 1, that means that is in error, right? What is the actual bit for that now? 0 only. We have only 2 possibilities here, right? This is called as error checking and correcting it. Correcting is very easy, right? Once you find out that this particular bit is in error, that means complemented, that is going to be your actual bit, right? This is very important, okay? So practice this. Definitely 100% you will get 1 or 2 questions on this. Okay, now you are done enough for this. We are done enough for this.
Sixth place is the error.
Yes.
So you convert the 1 to 0.
Definitely, error means what? We have only 2 combinations, right? Right. I am saying that I am sending you one apple and one some other orange. Right. Apple and orange. I am telling that I am sending only apple and orange. Right? And I am telling you that I am sending you apple. Right? But you have received orange there by mistake. That means what you are supposed to receive? Apple only. So this is only 0 and 1, right? So you have found out that that particular bit is in error. What is received is an error. but what is received is 1, but that is error. What is the correct one in that place? 0 only. Have you understood this? That's why it is auto-correction. Moment you find out that particular bit is in error, auto-correct it, that's all, right? It has become 1. Fine, okay? So just practice some of the questions on this. Now let us come back to this 7th and 8th, 9th question after certain topic, right? And what you are going to see here, next topic will be your Boolean functions. Boolean functions. Okay, somebody was asking about De Morgan's theorem. Okay, we'll come to that, don't worry, okay? De Morgan's theorem, all those things will come, okay? Now, hope you remember I told you about AND gate, I told you about OR gate, I told you about NOT gate, I told you about NAND gate, I told you about NOR gate, I told you about XOR gate, I told you about XNOR gate. All these are nothing but logic gates which implements logic functions. You all know what are the logic functions implemented in all these gates, right? Right? And you all know now that XOR gate is going to execute A XOR B. And what is A XOR B? A bar B plus A bar B plus AB bar. You have seen all those things, right? And here, to represent a logic function, we use Boolean variables. We use variable, like your algebra, x and y variable. Here also, we use variables to represent a logic function. And all these gates which you are actually studied is going to implement these logic functions, right? So now tell me, what are the basic logic functions? OR, AND, NOT, NAND, NOR, XOR, XNOR. You know about this much. Logic function need not be, these are the basic logic functions. It need not be only this. There are a lot of complex logic logic functions derived for a particular digital design. Your entire digital design is nothing but outcome of a final logic function, right? Say whenever if something is asked you to design, right? So something is asked you to design, ultimately what is the result you are going to give? Either in the form of a function or some input-output function, yes or no? That's what you are going to give, right? The same way in digital design, your final outcome of a particular task will be a logic equation, a logic function, right? And that logic function can be implemented using logic gates. Have you understood this, right? Okay. Now, step by step, we will see how can we design a digital system, okay, starting from a basic problem, okay, or basic requirement, and we'll see ultimately how we can end up with a logic function, and that logic function can be implemented using logic gates where you get all the outputs, right? It all starts from simple logic function, which I have already told you in my previous class. That's why I'm not going to spend much time in this, okay? Logic gates I have already told you, right? And I have told you how to write a Verilog program for that, okay? So practice this Verilog program, which are very important for you, because in the laboratory you are going to use Verilog program. So this is an AND gate, right? And you know AND operation, this is 2-input AND gate, this is 3-input AND gate, that's all, right? Okay, difference is only 3 inputs, okay? Now see here, Verilog program. I have already taken 1 or 2 sessions on Verilog program. How to write the Verilog program? Module name, these are the ports, where A and B are the inputs, Y is the output, okay? Now output is equal to, output Y is equal to, output Y is equal to A and B. So what type of implementation is this, tell me? No, that's true. Is it gate level? It's a data flow model. Then end module, done. Suppose if you want to change it to a gate model, and in the bracket y comma a comma b, that's all. Okay, this is the Verilog program. Okay, so I will just now quickly go through the other gates. What are the other gates? Tell me. You have OR gate, and I told you about NOT gate. Okay, and then this is going to be a NAND gate, right? NAND is nothing but a combination of AND and NOT gate. If you put it together, it becomes NAND. Okay, so can you tell me next gate will be a NOR gate? NOR gate is nothing but combination of OR gate and NOT gate. Have you understood this? Okay, so these are very basic gates. Now see this one. This is very important. Now your NOT gate is different, right? Your AND gate is different, and your OR gate is also different. These are different gates. OR and NOT gate is called as a basic gates, right? See, I have a circuit. Imagine I have a logic function and I have my logic circuit which has all these operations. Then definitely I should, wherever there is a NOT operation, I have to use NOT gate, right? Wherever I have AND operation, I have to use AND gate, right? Wherever I have OR gate, I have to use OR gates. So my entire logic circuit will have mixture of these three gates, yes or no? Mixture of these three gates, right? So there is no uniformity in that, right? There is no uniformity, right? Now, what is required from a fabrication point of view, that all these things are implemented using single gate. Single gate. If at all I have NOT gate, I should be able to implement the NOT gate using one gate. Suppose if I have OR gate, I should be able to implement that using OR gate, right? Suppose if I have, say, AND gate, I should be implement that AND gate with a single gate, right? And what are those single gates to be used in place of all these? Those gates are called universal gate. And which are the two universal gate? Your NAND and NOR is called as universal gate. Your entire logic diagram now is going to have either only NAND gate or only NOR gate, irrespective of what operation it does. Suppose you have OR operation, that OR operation is done using NAND gate. Suppose you have AND operation, that AND operation will be done by the NAND gate. Suppose if you have NOT operation, that NOT operation is also done by the NAND gate. That means the entire logic circuit will have only either NAND gate or NOR gate. Now, what you need to do that? What you need to know to get your logic circuit which will have only NOR gate or NAND gate, right? What is to be known is, you need to know how do you realize OR gate using NAND gate, how do you realize AND gate using NAND gate, how do you realize NOT gate using NAND gate. If you know how to do that, then you can construct your entire logic circuit using only one type of gate, that is universal gate, okay, which we will see in our next class. Now there is no timing here, so I will take it to the next, okay.